We are ready.
Thank you. Hi, everyone. Um, so Jonathan just asked a very important question and said, hey, there's not been any updates on the GitHub repo in a while. And Jonathan, you're absolutely correct. And let me tell you what's been going on. So you guys know, as we teach the class, we're using our learnings from that to write the book. But also as we're writing the book, we're trying to find ways to improve the way we teach the class. And that has been what's happened. But there's the other dimension of our larger family that doesn't show up here. And that comes to the point of we've added some new stewards that we could just tell were like moms. We added Magdi and Kimberly because they're moms. They have kids all over the world like I do. And so um, as we discussed things that we needed to do better planning and serve the family better, one of them was to move to make the integrated machine learning and AI GitHub organizational page more active. So I did successfully recently move the whole GitHub repo to that. I suspect, Jonathan, if you do a pull, or if now it will just come from that, but I haven't tested that yet. Also, what I was going to show you all this morning reflects some serious changes to our repo that I realized while I was writing the book. And so I wanted to show y'all the regression briefly and then go into the classification fake data generation also. But I'm hoping to push all of that, if not today, Sunday, but I will send update messages in family chat, tech chat, pipeline class chat, every chat that might be, remotely caring of that GitHub repo. And so I'll go ahead and share my screen now. I only use 3 different virtual video conferencing systems now, and it can get a little dizzying, remember which is which. All right. Now let me know if this is too much at once. I think it's at an okay size, but please let me know if it's not at an okay size. Can everybody see? Is that a good size, everyone? I don't know.
In general, it's a good size, but maybe if you want to focus on something, we need to make it bigger. But for me, for example, it's good for me.
I'm going to just go that just 10% bigger, and there we go. So I will be sharing this. It's not on the repo yet, but I wanted to give you a taste of it. In the regression, it's not horribly different, but now I'm really leaning on NumPy a lot in this case. And I wanted to walk you through this. First, I create just these 3 functions to help. I realized when you get into NumPy, you can do things so much more elegantly, but then you've got to think NumPy, and I want you guys to learn to think NumPy too. So that's why I did it. So first, we've got just a single feature creator. And these can all be modified very quickly, and I'll show you how we could do that. But I'm just doing a very simple send in a start point, send in a stop point, and say how many numbers of points do you want between those 2. And then to get the step size, we just say stop minus start divided by number of points. And then we use the power of, okay, I thought I had this as np.arange. Hang on a minute. I'm just going to check something. Oh, I do. This was the old version, which I planned to explain. Forgive me. This is the NumPy version. Okay, so each same thing I was saying, but then the points that I'm going to return, they're generated by an np.arange start, stop, step. And the great thing about NumPy, it's a little different than range in Python. Range is an iterator, and that just means that after you've used it once, it can go away. But that was why up here, I have preserved it by saying, after you create the range, make it a list. And then that way it will preserve it. So in the new way, it's just creating an NPA range, and that range is an array and it sticks around. Then this is how simple the initial noise envelope is. However, as you know, as you guys have learned now, we can turn this into a function too, so that if I pass in some variables, I can control how the envelope changes over a variable. And in this case, we could just keep this basic, you notice I'm just doing a return directly. This np.random.random samples uses the dimensions you want for an array. So you'd send in a tuple here, or a tuple as people say it. I got in the habit of saying tuple, it is tuple, even phonetically speaking. And this way you can define any dimensions for a uniformly distributed set of random numbers, which would represent our noise, but it's from 0 to 1. So I multiply it by 2 first, which is different from what I did above, and then I subtract 1. This way it's now from -1 to 1. And then the model is where you change things specifically according to the number of features you know you're going to produce. So it may be even better as you define these models to call them specific things. But for this example, I did a simple linear one here. I've got a polynomial, just squared here on the first feature. Then notice, though, I'm treating them all together. And if you're not familiar with NumPy, this means every row, first column. And this would be every row right here and second column, because we start from 0. So I'm doing this weight times the first column and doing the whole column. This weight times the first column squared, this weight times the first and the second column multiplied together. And then this weight times the second column, and this very small weight times the second column squared. So then I actually create that fake data. I define 300 points. I've got zeros in the dimension, an array of zeros, excuse me, with 300 by 2. And this is just something I can make alive if I want to print the shape, to print the dimensions. And I want to show you all a trick. I realize not all of you know this. And what's great is the keyboard shortcuts that we would use in VS Code, most of them I'm finding work in Google Colab, which is awesome. But watch this. I just am making that go back and forth very fast from commented to not commented. And I'm just doing that with Control/, and that's the slash next to the right shift key, the shift key that's under the enter key, that slash key, the one that's also the question mark key, just Control/. What's great about that is if you need to comment out a bunch of stuff, you could highlight it first and then just comment it all out very quickly that way. So that's a good trick to know. Kuyen would be very proud of me for showing you guys that. Hey, Valerie. So now I'm just going to implement what I just showed you. I create the first feature by doing feature column that way. And here's what I promised you. I could create the second feature by putting all of those values that I sent in right here inside another function and even scaling it. So again, where am I going? I'm going from 0 to pi and creating that many points between 0 and pi. And then I send all of X into model, but then I send a number of points and a scale of 7. Let's go back and look at that noise. That's the amplitude that will occur on that. That's just uniformly distributed noise in all dimensions. And we could go and I could change this so that it gave a different amplitude for each dimension. And we could do that another time if y'all want, but right now this is a pretty good starter point. And then before I put all of this into a data frame, and the only reason I'm putting it into a data frame is so I can use some of the great visualization tools in Pandas. But let's run some of this now instead of only talking about it. So I think this is already run somehow. Nope. Okay. You know that part of the Jeopardy music that plays while they're waiting for the contestants to fill in their answers? I wish that would just automatically play when I'm presenting to y'all from Google Colab, and it's doing that, taking a while. Okay, thanks for laughing on that one. I do my best, guys. Okay, so the data frame, we're passing in the data, but we're stacking it with a NumPy horizontal. That's what the H is for there. Oh, thank you. Sequence horizontally, stack arrays in sequence horizontally, column-wise. And that's exactly what I wanted. So I've got the 2 columns in X and the 1 column in Y. You'll see this, and I hope it never confuses you guys. All it means is use the existing dimension. When you see people using -1 with reshape, that's all that means. And make it the original dimension, but now make it that by 1. And so that's so it can horizontally stack X and Y. And then I create the column names. And then I look at the first 7 rows. If you leave this blank, it just shows 5 rows. And then we can look at the correlation, and you can see that your big brother or your dad, whatever you call me, hey, so horribly uncorrelated. That's what I was aiming for. But look how much gyration I had to put it through to get it there with this crazy thing and this crazy thing right here. I hope I'm not moving around too fast. So that's just a brief overview of that. I'll be making that available on our new GitHub location for the class. And I wanted to show you now, let's see how, oh, we're doing great on time. Look, and also before I go on, let me answer any questions on this part. Here is our first cell. So watching for any possible hands. And maybe most of you are just waiting for it to show up on GitHub for the class. Was that pretty clear? Is there any confusion over NumPy? Because that is something I would definitely want to spend a little extra time on if any of these points about how you can use NumPy were unclear. Okay, I'm taking this as a good sign, but it's okay to ask questions privately too. Send all questions today to Guy Sankari, because right now I am running on fumes. I was up to a little after 2 a.m. my time working on the book. Okay. No, you can send questions to me. I'll just get to them ASAP. Okay, so now the fake data for the classification. Okay, the function to create classification data. Now, I just want to talk about this philosophically for a moment. And with truly, I probably could have used this function for the other thing we just looked at, but I wanted to have 2 different versions for flexibility. And hopefully as we go through the book and we continue to teach y'all lessons, it will become more clear. But what I'm about to say will become more clear too as we look at the examples. it dawned on me the previous example I had prepared would not create noise along a path like the other three functions we discussed. And what I realized I needed was a way to send in a path as a group of points and create noise around each point. And that is all this does. But this part is truly, it's saying, okay, you send me in the NumPy seeds, but those seeds can be in any order you want. They can be individual points out in space, or they can be points along a path. And you'll see why that's valuable here very shortly. But this is a cool thing about NumPy. If I send in that group of seeds in a NumPy array, and I have this half range, it's just saying, I'm going to create noise for you, but you tell me from the point how far you want me to go out in each direction. So that's what I mean by the half range. And then you tell me, and I probably should change this name, points per cluster. That just means points per individual seed. So how many points do you want for each individual seed? And I find the number of seeds by just looking at the first element of shape, because I'm expecting at least 2 dimensions. And then the second one will be an array, and it'll tell me, it's basically an array of arrays, even in NumPy. It's 2-dimensional at least. And the number of dimensions can be seen by looking at the second element of shape. But because I know I'm passing in the classes, I'm subtracting 1, because 1 will represent the classes. Now, if you ever had 2 classes and they were both in this first dimension, this first array in the columns, let me put it that way, you would want to remove 2 columns so that you were only getting the dimensions. And modified correctly, I suppose we could pass in a new parameter called number of labels, and then you would subtract the number of labels from this so that you got just the columns that define the dimensions. Okay, now all we're doing here is creating an array for the points. Now, this is different from the seeds that we pass in. These are the points surrounding the seeds. And so I create a NumPy empty. Now, if you've never seen this NumPy array creator mechanism, it's like zeros, but it literally is full of not a numbers or nones. And it's the reason I got in the habit of using it is in my real work, some of my matrices can be gigantic, like 50,000 by 60,000 plus on each of those dimensions. So rather than fill it all with zeros that you don't need, you can just create an empty and then populate those using NumPy tricks as you go. But the dimensions of this are the number of seeds times the points per cluster, and that should have been points per seed, by the way. And then the numdims plus 1. And again, if we add the number of labels, this 1 could become number of labels. And this would define that empty array so that we should have we should have more points than seeds, unless you had 1 point per seed. Now, the labels, they're just going to be yes, in this case, the labels are in the first column. So I was just looking, this is just a slick way to say, oh, on an array that you pass to np.unique, give me the array you want unique values for, and I will tell you the unique values in it. Basically, it creates a set, so it doesn't have repeated labels. Now, for label in labels, which this is just going to be 1, by the way. Oh, no, excuse me. This is going to be for each label. It's now going through, and this is a neat NumPy trick. This is already a NumPy array, and it's saying, for each of the seeds that does equal the current label that we're looking at. And going from now I have a column label row, I'm skipping it. And that's why I do that. You know, I need to think about that. Nope, my bad. This is going, this is the columns. So this is defining which rows to use right here. And this is defining which columns to use. It's skipping the first column because that has the labels. But again, this could be number of labels to make it more general in case you had multiple dimensions of labels, that is. And then, yes.
Kimberly, I think she has a question.
Yes, Kim, thank you. Sorry, I'm focused over here.
Absolutely. No, I'm sorry. I just wanted to make sure. So any array that you're feeding into this, regardless of the size of the array, it's gonna spit out a label and the basic allocation of that one seed that comes out.
Good. What I'm saying is, when I pass this in for my fake data, I'm putting the labels in the first columns and then the dimensions for each label in every column after that. So it could be multi-dimensional, but for our fake data examples, because we want to visualize a lot, we'll probably only use one, maybe two labels.
So when you're creating this, you're creating basically a two-table structure that's going to come out of it.
Yeah, but they're joined as one structure.
Okay. Okay.
Yeah. So Kim, it'll be like it'll be labels. I'm holding up two because it could be one or more.
Right.
So I'm just, and then let's say it was 4-dimensional. Then in the 4 dimensions, it comes in that order. Wait. Now wait a minute. I mean to go left to right. And is this left to right? Is this on your left?
That's on my right, but that's okay. It's the reverse. It's fine. I get it.
Actually, I only have to look at my screen now because I turned off my mirror mode so that I could do that kind of stuff, and I forgot I did that. No, perfect question. Thank you for that. Just because I didn't, if anyone else was confused on that, I wanted to clear it up. Okay, now this is where it gets a little tricky. This is a function I used in the past. I'm going to take those centers and I'm going to tile them for points per cluster. And let me explain. Let me see if I can explain. I might forget what I did here. That would be horrible. I thought I would remember all this very well. It was a little tricky when I wrote it too, just so y'all know. I had to do a little bit of trial and error. But basically, let's look at this centers. That's right. It's just going ahead and creating placeholders for all the centers of the clusters. But I shouldn't have called it centers, I think. It's creating centers for all those points. So we've got, this just means, what are we going to tile? We're going to tile the centers array. And how much with which dimensions? It's going to be points per cluster and 1. And so, but again, remember, this is all doing huge things in parallel. We're just looking at each label to do all these massive parallel things. And another good thing to do, this is a trick I use. It could, oh, Kim, did you have a new question? Okay, good.
No.
I swear, I do this about 95% of the time, guys. I create the stupidest, simplest data set I can, just so I can really understand something like this. And I go through it tiny step by tiny step on that super simple data set. And I make sure I know what's going on with changing arrays and shapes. And I'll use a much simpler data set, and it sure brings things to light. But I know it can be hard to communicate this stuff, and I'm sure it can be even harder to understand it when it's hard for the presenter to communicate. So just know that I'm sympathizing. So now what's great about this is we have the number of noise points we need about those centers. And now we take that, we say, now that I know the number of noise points, I'm going to do a base noise for these labels, and I'm going to call that random sample function. And the dimensions I need for random numbers is the number of noise points that I just got and the number of dims that I got up here. I guess I don't need to do that because it shows you everywhere else dims occurs when I do that, which is awesome. Okay, then I adjust the noise. Again, I get the base noise. I'm just making it go from -1 to +1 right here. I'm scaling it by the half range, the amplitude. I could have called the half range an amplitude, and then I'm adding that to my centers. So again, the centers that I pass in, it's creating noise points according to points per cluster, which I really shouldn't rename that. It should be noise points per seed. It's creating the number of noise points randomly out from that seed, that center point. And then it's creating that noise and just adding it to centers. And all this is done linear algebra wise. It's all in parallel. It's doing it to these big columns. And then cluster array, I prepare this zeros matrix and add the labels to it. Then I do this start point, which is just the label times the number of noise points. Stop label +1 times the number of noise points. And now let me remember why I'm doing that. Cluster array, just noise.
Gabe has a question.
Yes. Guy.
It's not question. Let's say it's comment. I might lead to question. I don't know what will happen.
Okay.
First of all, I think when we are talking about where is the magic all happened, I think it's here between cluster array and the start and stop. Maybe start and stop, you are doing it because you have specific number of noise it's appearing. And then the label values, it's managing where to go. So
that's it. That's
basically,
it. Thank you.
Basically, we have the base noise, and with the centers, still we are creating everything as stacked over in that same place on the graph. But then when we add the noises and start and end, it will be spread over our old graph. This is how I see it.
That's right. This was a clever way to determine which noise, which label you were serving in the loop. As you were talking, I just remembered that. But then it puts it back into the points so that it's also including the labels, like I was forgetting earlier. So I know that's tricky. It was tricky to create, and I'm still wondering, is there a clearer way to create it? But it works super good. So I'm going to go ahead and we'll do some illustrations with it. And again, this is to serve in its most general way possible, creating fake data for classification. So now I wanted a flexible way to plot this stuff. And I had this idea, I will just, before we go on, put a pause in your mind for where we're at here. And I'm going to go back over to this. There was a fun new trick I wanted to show you. Okay, we're in a Google Colab notebook, right? And I shouldn't be able to rotate this plot, right? Oh. Okay, how to do it? Import plotly.express as px. Then figure equals px scatter 3D. and you do some stuff here. So if you just go look up, start getting to know Plotly, and look at how you look at some pages on how to do 3D plotting with Plotly. I basically got frustrated. I thought there's got to be some routine that will allow you to rotate 3D plots in Google Colab. And Plotly's amazing, guys. I really need to take more time to go learn it, but at least we can do it there. So I will try to update these when it does a 3-dimensional scatter plot for our classification fake data. I will try to update this to Plotly soon, but you guys can do it too once I add up the stuff. So this is just saying if the dimensions, doing the same thing we did before, are 2-dimensional, just do this way. And if it's 3-dimensional, do it this way. So that's all that's going on there. So trying not to reveal too much too soon here. I've got all these old seeds I've used from when I was developing this kind of stuff previously for some stuff I developed personally. And I'm just going to do 2 seeds here at first. So let's run those. And just as like I showed you, it's only doing every 40th point right now because this gets pretty big. But for every 40th point, there's the 0 label, there's the 1 label, and the fake dimensions for each of those. But again, I'm just sending in single points for each label in this case. And when I plot the results, that's what I see. And we can do this quickly, I'm going to add in these other 2 points. I just get more points now. And because it's saying, well, you're sending in all of these seeds this way, I therefore am going to create, you sent me 4 seeds, I'm going to create 4 classes. And sure enough, when we look at that now, we've got 4 classes. And you can see I've got my overlap a little too close. So maybe I want that to really challenge my classification routine. But if I want to back off on that because I'm just doing it initially, I change my half range, or my amplitude is probably more appropriate. Now you can see I get a little clearer boundary between my clusters. Now we've got those, and you remember before we put the data in a pandas data frame format, and then we stored it. But wait, there's more. We can store it as a JSON object. And so how do we do that? Well, we just take our Python points. So here, by the way, JSON, when you use the JSON routines, that's JavaScript object notation. When Tom doesn't know what an acronym stands for, Tom is not happy. So, I love being able to say them too. Say that with me in a Barney sense. JavaScript object notation. Jonathan, I did tell you about my creation for the UK version of Barney, right? His name's Blarney, and he teaches the kids from the local pub. Still working on that in my spare copious amounts of spare time. Anyway, PyPoints is just NumPy points to list. This is when there's something you've got to use that doesn't play nice with NumPy. You just turn it to a Python list. And JSON does not mind Python data structures, but it can't. It's rare that it can use NumPy stuff. So I create this. I use the context manager. And what's great about context managers, in case you didn't read my LinkedIn post, or you didn't go read Geeks for Geeks post or whatever, what's nice about this is after it finishes this operation, that is inside this indented block, it will close out everything and wrap it up. But we're going to just dump this, and these 2 parameters are essential in my mind. Everything's moving to Unicode, but it's not there yet. And I don't want it to ensure ASCII. I want to be able to pass in Unicode stuff when I feel like it. And indent you could use indent too to make things a little tighter. But I'm just passing pi points to the file I described up here. And you'll notice when we run this, if we go look at our file manager, there it is. Voila. So, but we want to be able to load that back. And in the real world, this data would have already existed. So we load it back and we get it. And we're looking at every 20th point now. And, but let's do another model. Let's have some fun now that we have this very, how should I put it? Flexible routine that even though it was a little complicated. Okay, now I'm going to have 400 seeds. And I'm only going to have 2 groups or 2 classes. And the group points are going to be, the number of points per group is just going to be the number of seeds divided by the number of groups. And just in case, and I can do this, I did some stupid math up here, I ensure it's going to be an integer because that's what I'll need. But also, I need it to be an integer for the routines I'm going to send in, because now when you do this in Python, even if they're both integers, it will return a float. And I'm glad Python's doing that for many reasons, but it puts the added burden on us now. Well, it shifts the burden. It shifts it from what we used to have to do to ensure it would give us a float if it needed to making sure it's an integer when we need an integer. It's no big deal. You just have to be aware of it. So the NumPy seeds, I'm going to initiate instead of empty. It's going to be zeros, and it's going to be the number of seeds, and it's going to be 3 because I'm going to have a label column and then an X and a Y column. And then I'm defining radians ahead of time to say I want an A range from 0 to 2 pi. This means I'm going all the way around a circle. And then it's going to stop at, this is start at 0, go all the way around a circle, step by this size. So the number of points per group. Then, and I want y'all to see if you can discern what I'm doing here before I show you. Oh, no peeking. For group num and radius in 0, 2, and 1, 1. So this is a group number, 0 and 1, the 2 classes, and the radius. I'm going to have a radius of 2 and a radius of 1. And the start for each of these groups and radii are group num times group points. And again, group num could be 0, so the start would be 0 in that case, and stop would be group num plus 1 times group points. That's just to say go from 0 to 1 and then from 1 to 2. But you'll see. It's just a sequence through the labels. Now my NP seeds, I'm going to get equal group num. And let's see. Yes. These are just these are creating the labels from my NP seeds in this row. This is creating the points for the first cluster, and then the points for the second cluster. And then I call my class above. And so I'm going to send the seeds. I'm going to say, this is my, hang on a minute. I'm just trying to remember myself from what I created. Yeah, points per cluster, sorry. Okay. Where was I? Here. Yes, I'm sending in all those seeds. The noise range amplitude is 0.25. It's kind of small. but then our radiuses are kind of small. And there's going to be 2 noise points per seed. So if I run this, I'm looking at every 80th point now because this got big and I only have the 2 classes. But does anybody have a guess from looking at this what we're going to see? I created 2 paths of points. All these points are on a path and only have 2 noise points per point. Well, as you see, I'm using 2 trig functions and I'm using them together. This is for the X. So this means it'll oscillate in X and it'll oscillate in Y. But how will it oscillate? Ta-da! Wow, it still does it. That's awesome. Okay, I hope that was instructive. So again, just so we can masterfully create fake data and do it very flexibly, we did this. Now, the sky's the limit here. I could have created 2 waves and one was below the other. And we'd have to find a classification routine that could divide the zones between those 2 wavy curves. But wait, there's more. The wavy curves could have also gone along this path. Their center, their average values, running average values could have gone along a slope and they wave up. And so they're doing this together as they go up. Because of creating this so flexibly at this level in this class, which is why I'd encourage you all to break it down and really understand what it's creating each time. By the way I do that is I just create a ton of print statements and sys.exit commands. I print it out with super simple data sets and look at it along the way. So I understand that part. I try different versions of it, just a single point or a path of points. And now I realize, oh, yeah, this is super flexible. I can create all sorts of fake data to push myself or to push my routines to see how they can do things. Thank you, Kim. Thank you. It's like I'm sitting in an audience and one person's clapping, but that's okay. I'll take the one clap. I hope that was helpful. So now what do we have? We have routines. Oh, can y'all see how this could actually create this class up here, when used correctly, can also create fake regression data. But I think that the one over here, I still can't get over that we can do that in notebooks now. That's so cool. These are still helpful, but they're a little easier to see at the outset than this one. This one's just a bit more fancy, a bit more sophisticated. So now, last time we talked on fake data, we went straight into modeling. So my promise is next week, we'll see how to do initial modeling with super clean, pristine data that we won't scale. Well, after we model it, it'll go so fast that we might have time to go into scaling and the advantages of it. But with this fake data, it's so clean and so easy to work with and purposefully. But the cool thing about fake data is you can keep adding problems at will to challenge yourself even more than real data. Okay, Kim, yes. I see you went to a hand raise.
I did. I typed it in the chat. Whoops. I typed it in the chat too.
Okay.
But I wondered if it would be possible to just provide some use cases of when we might use these tools.
So purely, yeah. In my mind, Kim, they are purely educational. But the reason I find that I use them most, not every, I'll give you an example. Not every clustering routine we would ever need to create exists on the planet. And in my own work, I have what I call a heterogeneous clustering algorithm. That's a fancy way of saying, hey, I need families of clusters, meaning I don't want you to group with other test standards, let's say. I want you to group a test standard with its nearest unit neighbor and its nearest numerical value and its nearest alpha elements, meaning a property name. And I want you to find a close-knit family that looks like it's living in one house and then go find the next group. And so I actually initially developed this kind of stuff for that purpose. But the lazy programmer, who's one of my gurus of choice, and I hope you will all own his stuff. He and I teach a little differently, but I love him. And he codes well. But by the way, I would not have my feelings hurt if some of you said, Tom, I think you code okay, but I don't like your code as much as my code. I love to hear that. That means you're getting happy with the cleanliness and clarity of your own code. That's a good state to be in. So when I look at the lazy programmer's code, I kind of feel like, yeah, that's good. It's not the way I would have done it. And he wants you to get to that point too. He's really insistent about, don't follow just his code it from scratch and compare to his code. And totally agree with him about that. It's harder to learn data science that way, but you get more insights. And he's constantly, when he's introducing new concepts, Kim, he'll create fake data, and he's really good at it. But he does it, I tend to find that I need to do it in a more sophisticated way because of the things I'm doing. And then I saw the immense educational value from creating the fake data when you're learning a new routine. Because now, Kim, you can exactly control the size of your data set and the complexity and the problems it has, so you can step through the learning in a careful way.
So just to interject there, if you wanted to try and figure out a number of different ways to tackle a problem, for example, you could use this as a way to create the data in a way that comes out the way that you think it should be to match that scenario.
Let me see if I can repeat your question in a more experienced way, and I mean that nicely. You are developing stuff for machine learning production. And you're looking at the data coming in and, hey, it doesn't look that bad. So you've created some routines and it looks good. The predictions are good. You fed back your learnings to your organizational counterparts. They thanked you. It's in production. Now you're doing this. And this is a silly scenario, but it's possible. You think, I want to harden my routines, but the data that's coming in is this way. What if this happens or that happens? Oh, I can take what's happening in production offline, run it in a sandbox area, a play area, and start to inject some dirty data into the incoming data assets and see how my routines handle it. And now you can start to create, oh, okay, when that happens, I'm going to create this little element in my pipeline that will deal with that issue. Oh, I'm going to create another fake data thing. By the way, I'll show y'all something real quick. Let's say you're in LinkedIn and you think, I love Cuyin Tran now as much as Tom does. If y'all remember the little character on Madagascar that was the sacrificial offering to the animals from the zoo when they landed on the island, and he was looking like this, hoping they wouldn't eat him, but the whole other animals put him out. He said, when they didn't eat him, he loved them so much, and he said, compared to how much you guys, compared to how much I love them, you hate them. And I'm a big Cuyin Tran fan. I think what she's doing for the community is really wise. And so I'm going to go here and I think, oh, she did that post on this thing. So I'm going to go look at her profile and I'm going to see all her activity, but I don't want to see all her activity. I just want to see her posts. So I can go find that post on when she did Faker. And I might have to scroll a while, but if I have to scroll too horribly long, by the way, we're now mentioning her teaching of Faker in our book because it was so valuable to what we were working on. Okay, it may be that it was too long ago. Oh, there it is. Now I could have just typed in the search, Quyen Tran, create fake data, and I would have found this in a list of results. But Kim, here's another cool thing you can do with regard to what we did. You can loop and create a whole bunch of new colors that your routine hadn't one hot encoded, for example, or create new names if you were doing that, or addresses. And so Faker is a great way to create this kind of data. And there's possibly many others out there, but I find random and doing these areas, that's a lot of that space that I work in. But that's when you remember someone did a valuable post that you didn't save or didn't get to go try yet. You're like, I can't lose that. Of course, Quyen, you could probably direct message her in our Slack, and I think she'd answer you because she's part of our family now. Okay, I hope this was helpful. Next week, I promise even more fun, where we will learn how to even create a classification boundary between those two rings. Oh my, what a great promise.